Hi and welcome to our channel. We are in lecture 4 of quadratic equations. In this lecture, we are going to discuss what is the graph of a quadratic equation and what is the sign of a quadratic equation and also some problems based on this concept. Without wasting our time, we'll start. What is the graph of a quadratic equation? In our 10th class, we already discussed that the graph of a quadratic equation, and we already ran in that in the 10th class that the graph of a quadratic equation is parabola, either upward parabola or downward parabola. That is, if we take y is equals to ax square plus bx plus c, this is a quadratic expression. It is not an equation because here equal to 0 is not there, equal is not there. So here this is a function. This is a function actually. Ax square plus bx plus c is a function which we can take as either y or f of x. Okay. Now if I draw the graph for this function ax square plus bx plus c, then what I will get? I will get a parabola. Like this I will get. Like this I will get. Here this point we call as vertex. This point we call as vertex. Okay, this is upward parabola and we may get downward parabola also. We may get downward parabola also. Here it is the vertex. Vertex. Okay. Now who will decide which one we will get, either upward parabola or downward parabola? Who will decide means here A will decide that. Okay, if A is greater 0, we will get upward parabola, and if A is less than 0, then we will get downward parabola. First of all, you need to know these two things. If A is greater 0, we will get upward parabola, and A is less than 0, then we will get downward parabola. Okay, now if A is greater 0 and also 3 cases arises. 3 cases arises. Now we are going to see that. If y is equals to ax square plus bx plus c and a is greater 0, then 3 cases arises. If discriminant is equals to 0, then the graph will be like this. A is greater 0, therefore we are taken upward parabola. Discriminant equal to 0, roots are real and equal. Real and equal means we need to get alpha equal to beta. It should touch x-axis at only one point. Already in 10th class we already learned. The roots means, zeros means how many times it will touch, it will intersect the x-axis, those many roots will exist. Similarly here, only 2 roots, but roots are equal, therefore we have to get it has to touch the x-axis at only one point. That point itself, it is alpha is equals to beta. Similarly, if discriminant is greater 0, we have to get real and unequal. Real roots means it definitely intersect the x-axis. Okay, this is the x-axis and it is intersected, but here a is greater 0, that's why it is the upward parabola. Okay, here we have 2 roots, that is alpha and beta. It intersect the x-axis at 2 places, that is one is alpha and one is the beta. These 2 are the roots itself. Actually for this we have zeros, but if it is y is equals to 0 means it is x-axis only, right? Y equal to 0 means if I substitute y equal to 0, I will get the roots for this expression, this equation. Okay, so that those roots are alpha comma beta. Now discriminant is less than 0. Discriminant is less than 0 means what will happen? Here roots are imaginary, means it doesn't touch x-axis. Therefore here this is the x-axis and the graph will be like this. It is a is greater 0, therefore it is upward parabola. Similarly, if a is less than 0, again 3 cases arises. That is discriminant equal to 0. Discriminant equal to 0 means it should touch at x-axis at only one point. It is this point, alpha is equals to beta. But here a is less than 0 means the graph will be downward parabola. Here discriminant is greater 0. Discriminant is greater 0 means it should intersect the x-axis at 2 places. One is alpha and one is beta. Here a is less than 0 means the graph will be downward parabola. Similarly here, discriminant is less than 0. Discriminant is less than 0 means here the roots are imaginary. Imaginary means it doesn't touch the x-axis. Okay, therefore I have taken like this. Okay, here a is less than 0 means it is downward parabola. Okay, I hope you got this one. Now we'll extend this concept. Okay, once observe these two graphs. Here this is a greater 0 and this is also a greater 0. If you observe this one, this graph is always positive. Why you are saying always positive? The value of this graph is you are getting always positive because it is above the x-axis. It is entirely above the x-axis. Entirely above the x-axis. If you observe, for example, let us take it is 0. At 0, you are getting positive. At 1, you are getting positive. At each and every point on the x-axis, you are getting the positive value. This is positive and here it is also positive, this value, and this value positive, this value, and everything is positive. Here you are getting positive, here also you are getting positive, and here also you are getting positive, and here also you are getting positive, and here also you are getting positive, here also you are getting positive. Means at each and everywhere, okay, each and every point on x-axis, you are getting the value of the graph is positive. When you are getting value of the graph is always positive, for all values of x, you are getting y is positive. For example, our y is equals to ax square plus bx plus c. For all values of x, you are getting y is positive. When you are getting a is greater 0 and discriminant is less than 0, when a is greater 0 and discriminant is less than 0, definitely you will get the value of the graph is always positive. Now once observe this one. Here you are getting at this point you are getting positive, at this point you are getting positive, at this point you are getting positive, at this point also you are getting positive, and at this point you are getting positive, at this point you are getting positive, at this point also you are getting positive. But at this point you are not getting positive, you are getting negative. You are getting negative value. You are getting negative. Where you are getting positive? You are getting positive. For example, if it is minus infinite and it is plus infinite, you are getting positive from minus infinity to alpha, okay, and from beta to infinite, okay. If it is greater or equal also he is asking, you have to take closed bracket, and in between union you have to take. If he is asking only positive, means you have to consider here closed bracket. These things we'll discuss in a wavy curve method. Okay, now once observe here. So here you are getting positive in this interval, you are getting positive for this graph. Okay, for this graph you are getting in this interval positive. Where you are getting negative? In between alpha and beta. You are getting negative. This is for greater or equal to. Okay, for greater means only you will get minus infinity to alpha union beta to infinite. This is for only greater 0. Okay, here it is positive as well as 0, but it is only greater 0 for this unit, right? But negative where we are getting? From alpha to beta. Only you are getting. In this only you are getting negative. Okay, where you are getting negative? From alpha to beta. Otherwise you can write alpha less than x less than beta. Also you can write. Very simple. Here you are getting positive, here you are getting positive. In this you are getting negative. From here to here you are getting negative. When you are getting like this, if a is greater 0 and discriminant is also greater 0. For this case, discriminant is greater 0. If you want, you can check alpha comma beta. Two roots we are getting. Okay. Now we'll see two more cases. Those are if a is less than 0 and discriminant is less than 0. If a is less than 0 and discriminant is greater 0, what will happen? Okay, a is less than 0 means definitely we will get, if a is less than 0 and discriminant is less than 0, we will get the graph like this. Less than 0 means downward parabola, and discriminant less than 0 means no real roots, imaginary or complex conjugate roots. Okay, and a is less than 0, discriminant is greater 0. Since a is less than 0, we will get downward parabola. Discriminant is greater 0, we will get two real roots. Those are alpha comma beta. Okay, now what is the sign of this quadratic equation? Now we'll discuss. If you observe here, at each and everywhere, at each and every point of x, for all values of x, we are getting negative. For all values of x, we are getting negative. If you want, you can check. Everything is in in below the x-axis only. Okay, so here also we are getting negative, here also we are getting negative, and here also we are getting negative. Therefore, for all values of x, for all values of x, this graph is negative. This is negative for all values of x, for all values of x. Okay, similarly, if you observe this one, a is less than 0 and discriminant is greater 0. Now here, if you observe, here we are getting negative, here we are getting negative, at this point we are getting negative, at this point we are getting negative, at this point we are getting negative, but at this point we are getting positive, and here we are getting positive, and here we are getting positive, here we are getting positive. At this point we are getting negative, and at this point we are getting negative, at this point we are getting negative. Now if you observe here, from where to where we are getting negative, and from where to where we are getting positive means, here we are getting positive, here we are getting positive, and from minus infinity to alpha and from beta to infinite we are getting negative. Where we are getting negative? Negative we are getting from minus infinity to alpha and beta to infinite. Minus infinity to alpha union beta to infinite. Okay, here if he is asking for less than or equal to 0, you will get here closed bracket, less than or equals to 0. Okay, less than or equals to means less than 0 means negative, equals to means equals to also possible, means we need to include alpha comma beta. If it is only less than 0, if it is only less than 0, then minus infinity to alpha open bracket union beta to infinite. Okay, right, now where we are getting positive, we are getting positive from alpha to beta, from alpha to beta, from alpha to beta. This is for greater 0, and for greater or equal to 0, closed bracket alpha comma beta. Okay, why we are considering here closed bracket means the closed bracket indicates includes. Here equals to 0 means at alpha we are getting 0, at beta we are getting 0. Therefore here if equal symbol is there, you need to take the closed bracket. This is the difference between closed and open bracket. Closed bracket means included, open bracket means excluded. Here if you observe, only is asking less than 0. Less than 0 means negative only is asking, he is not asking for 0. Okay, that's why here I have taken open brackets. Here he is asking less than 0, also he is asking equals to 0. That's why here we considered closed bracket. I hope you got these four concepts. Okay, now we'll discuss some problems based on this concept. First question, for all values of x, x square plus 2ax plus 10 minus 3a greater 0, then the interval in which a lies in. He is asking that for the quadratic equation we are getting always positive. When we will get always positive? We already know that if the graph is like this, then only we will get always positive. If it is like this, we will get always negative. Okay, so for all values of x, it is positive only. Okay, now what are the conditions if you want to get this kind of graph? This is upward parabola, we need to get a greater 0, and this is having complex conjugate roots, definitely it is discriminant less than 0. So these two we need to use to solve for x. Very simple. If we know the conditions, then we can easily solve. A is greater 0, a is 1, it is already 1 is greater 0, no need to take again, it is a greater 0 only. X square coefficient is 1 only. So here I am writing x square plus 2ax plus 10 minus 3a, which is greater 0. So already a value is 1, coefficient of x square is 1, it is greater 0 only. Now what we need to take here, discriminant less than 0, discriminant less than 0. What is discriminant? Discriminant is b square minus 4ac. Here b square minus 4ac is 2a whole square minus 4. A value is 1, c value is 10 minus 3a, which is greater, which is not greater 0, which is less than 0, because our condition is discriminant less than 0. Now what is 2 a whole square, which is 4a square. Now minus 4 into 1 is 4, 4 into 10 is 40, and minus into minus, which is plus, 4 3s are 12a, which is less than 0. Now we need to solve this one. In this, a is 4 is common, so if I take 4 common, what I will get? A square minus plus 3a square plus 3a minus 10, which is less than 0. Now what are the roots for this equation? 5 2s are 10, and here we are having 3, means we can easily take plus 5a minus 2a minus 10, which is less than 0. Now if I take a common, it is a plus 5. If I take minus 2 common, which is a plus 5 less than 0. From these two I can take a plus 5 common, so which is a plus 5 into a minus 2 less than 0. Now this is a minus of minus 5 into a minus 2 less than 0. Now what are the values of a? In which interval? Okay, in which interval a lies to get this value is greater 0, means here if you know the direct formula, then you can write the solution. If you don't know, use the wavy curve method, and I will upload the videos wavy curve method also. Okay, just watch those videos and you will get there. Okay, now here a minus of minus 5 into a minus 2 less than 0 means if you observe here, let us take what are the values of a here? What are the values of a? If I take a minus 2 equal to 0, I will get 2. If I take minus 5 here, minus 5 means just I have taken the roots of this quadratic equation, minus 5 and 2. Now let us consider here minus infinite, and let us consider here infinite. Okay, let us consider here minus infinite and consider here plus infinite. Now take any number between these two, any number between these two. If you observe here, minus infinite and minus 5 is there, so in between we have minus 6, minus 7, minus 5.5, everything are there, so we can consider minus 6. Now if I substitute in this minus 6, what I will get? In this minus 6, if a is equals to minus 6, so what I will get? Minus 6 plus 5 is minus 1 into minus 6 minus 2, which is minus 8. So we are getting plus 8. Plus 8 means we are getting positive. Positive means just indicate here. Okay, so in between these two we need to consider one more. Okay, right? Minus 5 to 2, in between we have 0 is there. So if 0 is there in between, just consider that 0 only. Okay, just substitute 0. A is equals to 0. So what you will get here? 0 plus 5 is plus 5 into 0 minus 2 is minus 2. So what is the product we are getting? Minus 10 means we are getting negative. Minus 10 means negative. Just to consider the negative only. Okay, negative. Next consider negative means you have to take here. Okay, positive means you have to take here. Now take any number between 2 to infinite. What you will get from 2 to infinite? 2 to infinite means 3. Just substitute a is equals to 3. What you will get if you substitute a equal to 3? 3 plus 5 is 8. Next 3 minus 2 is 1. So 8 into 1 is 8. We are getting positive. Just to take here positive. Now just draw the wavy curve like this, and in between we are getting negative, and here we are getting positive. Simple. Now what we need? We need negative. We need negative. Less than 0 means negative. Where we are getting negative? In between these two we are getting negative. Therefore our answer is minus 5 to 2. Minus 5 to 2 means here less than, only less than is there, not equal symbol. Therefore we have to consider open bracket. Otherwise we can simply write this one as minus 5 less than a less than 2. This is our final answer. In between minus 5 comma 2 we are getting negative. We are getting negative. Therefore what are the values of a? What are the values of a to get this value is always positive? This value is always positive means from minus 5 to 2. This is our answer. Option B is our answer. I hope you got this question. Okay, it's very simple. What are the conditions we need to know? Here the a greater 0 and discriminant less than 0. Already a is greater 0. It is already given. So we need to take that discriminant less than 0. I have solved for discriminant and I got the values of a. minus 5 to 2. Okay. Once observe this one, we'll solve the next problem. Second question. Find all values of a for which the inequality, this is the inequality, is satisfying for all real values of x. Again, he is asking, this is a quadratic equation. For what values of a, this quadratic equation will have negative. Negative for all values of x. Negative means what? Negative means what? Like this you need to get. Like this you need to get. Yes or no? Negative. For all values of x, we are getting negative only. For all values of x, we are getting negative. Therefore, this is the case we need to consider here. When we will get this kind of graph, if a is less than 0 and also discriminant is less than 0, we will get a is less than 0 and discriminant less than 0. Now, a is less than 0. First of all, what is the inequality given? A minus 4 into x square minus 2ax plus 2a minus 6, which is less than 0. Now from this, what is a here? So you will get confusion. Therefore I am taking here capital A. Capital A means here this one. Okay. Now which is less than 0? Less than 0 means a minus 4 less than 0. This is the first case. Okay. This is the first case. Now from this, what you will get? A is less than 4. A is less than 4. Next, what is the second case we have? Second case is discriminant less than 0. What is discriminant less than 0? If you observe in previous case, already it is given that a value is 1. It is already greater 0. No need to take the case 1. So, but here we need to take the case 1 because a minus 4 is given in coefficient of x square. Therefore, we consider that a minus 4 is less than 0 because a should be less than 0 to get this kind of graph. Now, discriminant less than 0. What is discriminant? B square minus 4ac. B square means minus 2a whole square minus 4. A value is a minus 4. C value is 2a minus 6, which is less than 0. Now, if I expand this one, what I will get here? 4a square minus 4 of, just multiply these two, a into 2a, which is 2a square. Next, a into minus 6, which is minus 6a, minus 4 into plus 2a, which is minus 8a, minus into minus plus 24, which is less than 0. Now take 4 common and send that side, it will become 0. Therefore, what we will get here? A square minus, I am multiplying minus inside, minus into 2a square minus 2a square, minus into minus plus 6a, minus into minus plus 8a, and minus into plus minus 24, which is less than 0. Now a square minus 2a square, which is minus a square, plus 6a plus 8a, which is plus 14a, and which is minus 24, which is less than 0. Now for a square we have negative, so it's better to multiply with negative. So if I multiply with negative, a square minus 14a plus 24 greater 0 we will get. Here inequality will be reverse if I multiply with minus. If it is greater 0, if you multiply with negative, you will get less than 0. If it is less than 0, if you multiply with negative, you will get greater 0. Okay, you need to know this one. For example, minus a is greater 2. If I multiply with minus, a is less than minus 2, we will get. I need to multiply both minus and I need to change the inequality. Okay. Now, just observe here. So, what are the values we can take here? 24 we need to get, and 14 we need to get. 12 2s are 24. 12 2s are. So, what I can take here? 12 2s are. Okay. Means a square minus 12a minus 2a. 14a I can write as minus 2, minus 14a we can write as minus 12a minus 2a plus 24 which is greater 0. Now if I take a common here, I will get a minus 12, and if I take minus 2 common, a minus 12, I will get greater 0. From this I will get a minus 2 into a minus 12, which is greater 0. A minus 2 into a minus 12 greater 0. Now what you need to do, just again take the number line here and indicate the roots 2 comma 12. Now what I will get here, if I take here minus infinite and if I take here plus infinite, if I substitute any number in between minus infinite and 2, in between minus infinite and 2 we have 0. So if I substitute 0 here, 0 minus 2 is minus 2, 0 minus 12 is minus 12, minus 2 minus 12, we are getting plus 24, positive we are getting. Similarly, in between 2 to 12, we have 3. So if I substitute 3 minus 2, which is 1, 3 minus 12, which is minus 9. 1 into minus 9, we will get minus, therefore it is negative. Similarly, from 12 to infinite, any number you can take, which is 13. So 13 minus 2, which is 13 minus 2 is 11, and 13 minus 12 is 1. 11 into 1, which is 11, positive we are getting. Therefore, we can draw like this, and like this we will get. Okay. Now, from this, greater 0 is asking. Greater 0 means from minus infinity to 2 and 2 to infinity we will get. From minus infinity to 2 union 2 to infinite we will get. 2 to infinite we will get. But this is not our answer. This is not our answer, because this is the case 2 answer. This is the case 2 answer. But we have one more, that is case 1 is also there. So we need to take the intersection of these two, because this has to satisfy and this has to satisfy. Therefore, in order to satisfy both the cases, we have to take intersection part. Now, what are the roots we have here? One is 2 and other is 4 and other is, which is 12. Okay, 12, and we have here minus infinite and we have here plus infinite. Very simple. Listen carefully, you will get. What is the first case we have? A is less than 4. A is less than 4 means, which is minus infinity to 4. Less than 4 means less than 4, minus infinity to 4. So this is the case you will get. From here to here you will get. Okay, here to here. Next step. What is the second case? Minus infinity to 2, and you need to take like this. You need to take like this. Okay, minus infinity to 2, from 2 to infinite, minus infinity to 2, and 12 to infinite, not 2 here, 12 to infinite. So 12 to infinite means like this, like this. Now you need to take the same line here. Don't take like this, don't take like this, because this one and this one belongs to same condition. Therefore, we have to consider in the same line. Okay, now just observe here, this case and this case, both the case intersection part, where you are observing at a time two lines. Here you are observing at a time two lines. Therefore, our answer is from minus infinity to 2. From minus infinite to is our answer. From minus infinite to is our answer. From minus infinite to is our answer. All are open brackets, because there is no equal symbol here. Therefore, we have to consider only open bracket. For infinite, every time we need to take open bracket only. Okay, we'll discuss that one later. Infinite is not existed. That's why we have to consider always open bracket. For 2 also open bracket, because here there is no equal symbol here. If it is equal symbol is there, then we can change it. Okay, but here open bracket only we need to consider. I hope you got this one. First of all, you need to read the question, and here it is given less than 0. When we will get less than 0 quadratic equation means, for all values of x, when we will get negative means, like this. For this, we have two cases. Coefficient of x square should be less than 0 and discriminant should be less than 0. I have solved both the cases and I have taken the intersection part. Okay, very simple. Now observe this one and we'll